Now, let us shift our attention from measuring the volume of liquids to measuring the volume of solids. To determine the volume of a regular solid, such as a brick, first measure the dimensions of the object. Then multiply the 3 dimensions and their units. In this example, we measured in centimeters. Therefore, the units for volume are recorded as cubic centimeters. To measure the volume of an irregularly shaped object, such as a rock, measure the volume of the liquid displaced when the object is submerged. To do this, measure the initial volume of water in a graduated cylinder, submerge the irregular object, and measure the final volume of the water. The difference between the initial volume and the final volume is the volume of the object. In this example, the initial volume is 50 milliliters. Dropping the rock in the graduated cylinder causes the water level to rise. The final volume is 81 2/10 milliliters. To find the volume displaced, subtract the initial volume from the final volume. Doing so yields 31 2/10 milliliters. So the volume of the rock is 31 2/10 milliliters. Typically, the reason to measure the volume of an irregular solid is to determine the density of the solid. Density is the mass of a substance per unit of volume. The formula for density is mass divided by volume. You could also find this formula by looking at the formula chart. Using a balance to measure the mass of the rock, we determine that it is 74 88/100 grams. Since we know that the volume of this rock is 31 2/10 milliliters, and the mass of the rock is 74 88/100 grams, we can calculate its density. When we divide the mass by the volume, we arrive at 2 4/10 grams per milliliters as the density.